Dear students, in this video we are going to see 2.1 and 2.2. Okay. Now you see the definition of a complex function. Okay. Now w is equal to f of z is equal to u of x comma y plus iv of x comma y. This is called a complex function. Okay. That is f of z. Okay. Here you see z plane is nothing but real axis x and imaginary axis y. The w plane is nothing but real axis u, imaginary axis v. Okay, here the function is w is equal to f of z. Okay, here this is the domain, here this is the range of f. Okay, so now here you see this question, write each of the following functions in the form of w is equal to f of z equal to u plus iv. Okay, here actually u must be in terms of x and y. Similarly, v must be in terms of x and y. Okay, but here real part of the function is u, imaginary part of the function is v. Okay, now you see here the Cartesian form of z is nothing but x plus iy. Okay, here real part is x, imaginary part is y. Okay, in the complex number. Okay, similarly here in this complex function real part is u, imaginary part is b. Okay, now you see here this is the given function 3z squared plus 5z plus I plus 1. What we are going to do, you have to write this function in terms of this. Okay, now for that you take z equal to x plus iy. Now what we are going to do, w is equal to f of z is equal to, you put here for z x plus iy, for z x plus iy. See that x plus iy square, here plus 5 times x plus iy. Okay, so that here you expand this, so that 3x square plus I square y square plus 2ixy, and then here you multiply, means you distribute 5 here. Okay, so that now here you write here this is the real part, this is the imaginary part. You see the function f of z is written as real part as this plus I times this is imaginary part, so that now this is called u, this is called v. Okay, so now this is the function f of z. Okay, similarly you see the second question. Now what is h of z is equal to z plus I divided by z squared plus 1. Okay, now here similarly you take the Cartesian form of z, that is x plus iy. Now you substitute here, z is x plus iy, z squared is x plus iy squared. Okay, now you see w is equal to h of z. Okay, now here first you expand this by the rule, then here x squared minus y squared plus 1, this is a real part. Okay, x squared minus y squared plus 1, this is the imaginary part. Okay, so that now you see whenever you have in the denominator the complex number, you must take the conjugate, means here you have to change the sign. Here it is plus, so you have to change into minus, take complex conjugate, and then here you see multiply here and here, and then simplify it, you will get the answer. Okay, that you have to try it. Okay, then you can write here u and v. Okay, like this, like previous question. Okay, so now that's it. Now describe the range of each of the following. Okay, now here from the z plane to w plane we are going to find the transformation. We are going to find the transformation. You see here f of z equal to z plus 5 for real part of z greater than 0. We have to find the range. Describe the range of each of the following. Okay, now how? See, let z equal to x plus iy. This is a Cartesian. Now what we are going to do? You substitute this here in the given function, so that x plus iy plus 5. Then what you do? You write real part, then imaginary part. Okay. Now what is the real part? What is the name of the real part of the function? That is u. Okay. What is the imaginary part of the function? That is v. Okay, so now this is u. Okay, so u is x plus 5, that is here. V is nothing but y. Okay, now u is x plus 5. Okay, so here you find x. What is x? That is u minus 5. Why I find x? Because let's see the question. Real part of z is greater than 0. For this one only we are going to find the range of the function. So now real part of z is greater than 0. That is given here. So that I am writing here. See, given real part of z is greater than 0. What is the real part of z? Real part of z is x. So that now you see real part of z is greater than 0. What is real part of z? That is x. So x is greater than 0. But what is x? What is x here? What is x you found? That is x minus 5. So now substitute here. So x is u minus 5 is greater than 0. Okay. Now what is u? U is u. Replace this here. So u is greater than 5. Okay. What is u is greater than 5? Again, what is u? U is real part of the function. That is real part of w is greater than 5. Okay, this is the final derivation. But now you see how to draw the graph of this. Okay, u is greater than 5. Okay, already I told you. See, this is the w plane. Okay, why I am telling w plane? Because this is the real axis u, this is the imaginary axis v. So this is the w plane. Okay, so now here u greater than 5 means you count here 1 2 3 4 5. Here what is the symbol? Greater than. So that here you put the cutter line, for example, like this. Okay, these points are not included in the graph. Okay, after that, see, u greater than 5 means all this. Okay, u greater than 5, all this. See, that's why I put arrow mark. All this or the range of this. Okay, so that's what we have calculated. See, here we have calculated and then drawn in the graph also. Okay, that's it. Now see the second question. Now find the range again for this function for real part of z is equal to 1. Similar idea. You take z equal to x plus iy. Substitute here. It's very simple. Z square x plus iy square. That is nothing but a plus b whole square. Rule. You apply the rule. Now here what is the real part? X squared, and then here I squared is minus, so y squared. So now that's why a real part. That is x squared minus y squared is the real part. What is the imaginary part? That is b of x comma y is equal to 2xy. This is the imaginary part. Okay, 2x and y. Okay, except I. Okay, now this is u, this is v. Okay, now what is given? Real part of z is equal to 1. So real part of z, what is the real part of z? Real part of z is nothing but x here. Okay, real part of that is x. Okay, so now x is equal to 1. Okay, but now you substitute this x value here in u and v. So now we can get u in terms of 1 minus y squared, v in terms of 2y without x, because we substitute x here 1, here 1. Okay, so now from this one you can find y. See, v equal to 2y, you find y. How to find y? Y is equal to b over 2. Okay, then you substitute y is equal to b over 2 here. You substitute y is equal to b over 2 here, so that u is equal to 1 minus, you see here, u is equal to 1 minus y square. For y you substitute here, okay, b over 2, so that b squared by 4. Okay, now this is the one we require. We are going to draw in the w plane. Now you see here what is given in z plane. Real part of z is equal to 1. So in z plane, real part of z means what? That is here x is equal to 1. Real part of z is x. So x is equal to 1. That is the graph, straight line. In w plane, what you are going to get? That is u is equal to 1 minus v squared by 4. Okay, this is u, real axis. This is v, imaginary axis. But what is this? This is the equation of parabola. You have to draw this one. Okay, that's it. Now take this question. Find the image of modulus of z minus 2i is equal to 2 under the transformation w is equal to 1 over z. Okay, now you see here, see, what is the transformation? W is equal to 1 over z. This is nothing but f of z. What is f of z? W is equal to f of z. Okay. Now what is z? Z is equal to 1 over, because you cross multiply here. Z equal to 1 over w. Okay. We know that Cartesian form of z is x plus I y. Okay. Then what is w? U plus I v. Okay. This is the z plane. This is the w plane. Okay. Now z equal to 1 over w. We know that here, from here you substitute w, u plus iv, and then this, how you will get? You take the conjugate of this, multiply here and here, you will get this. Okay. Then here you write, you see u minus iv by u square plus v square, but this is equal to what? Z, because z equal to x. Okay. Now you see here, this one you can write, see here real part is x. Okay. So x is equal to real part. What is real part here? U by u square plus v square, this one. Here I, y is the imaginary part. Y is equal to here minus b by this. Okay. So that I can write x like this and y like this. Okay. Why I am writing this one? Because given circle is modulus of z minus 2i is equal to 2. Here z is given, so I had to write for z here. See, z is x plus I y. So now you substitute. What is, see, z equal to x plus I y. Then you take, this is real part. Then here take I. Then y minus 2 is the imaginary part. Here we have modulus. So what we have to do? Put square root of x squared plus y minus 2 whole square. Okay. So that is equal to 2 square. 2 squared is 4. Okay. So now y minus 2 whole square. Okay. So a squared plus b squared minus 2ab. Here there is an error. Here it will not be 4, here 2. Okay. Because if you take I outside, y minus 2, then apply modulus condition, you will get this. Okay. Then you make simplifications, so that here you are getting x square plus y square minus 4y equal to 0. Okay. Here we have to substitute in terms of x in terms of u and v. That's why we have calculated this. Understand? Here y we calculated this one already. Now here x squared. What is x squared? You put x is equal to u by u square plus v squared here. For y you put this value here. For y put this value here. So that you can find the conversion. Now you see here, you simplify this one, so that 1 is equal to minus 4 times v. So what is v? That is equal to minus 1 over 4, or imaginary part of w. Okay. Why? Because w is equal to u plus iv. This is real part, this is imaginary part. So that here v is equal to minus 1 over 4 in the graph. Okay. So v is equal to minus 1 over 4 in the graph. Okay. This is the line, equation of line in the w plane. This is w plane. Okay. That's it. Now you'll see the limit compute. Limit z tends to minus I z cube plus 1 divided by z square plus 1. Okay. This is very simple. Already we have studied in calculus 1. See, apply this rule to expand this one. Okay. And then you expand, and then you cancel this, and then you substitute the limit in numerator and denominator, so that you can find the value, that is 3 over 2. That is the value of this given limit. Okay. Second one, you see here we have to find the value of limit z tends to infinity 4 plus z squared by z minus 1 whole square. This is a given question, but you see here given limit is infinity, z tends to infinity, but here you change it, z tends to 0, but you can do as it is. But here if you change z tends to 0, you have to write z in terms of 1 by z. You see here z power minus 2. For z you put 1 by z. Okay. So that you can change here z tends to 0, because 1 by 0 is infinity. That's why we are changing here. Okay. After that you simplify it, and then you substitute the limit z tends to 0 in the numerator and denominator, so that you can find the value 1. Here we have to find this limit, numerator imaginary part of z divided by z tends to 0. Okay. Here we can find in two cases. First one, real part of z equal to 0, z tends to 0, find this value, that is minus I. Second part, limit imaginary part is 0, z tends to 0, then it is not exist, limit does not exist. Okay. That's it. Thank you.